Okay. Hello class. Thank you very much for joining us today. And we are going to move on with what solving our questions on our 30 questions per day. And I said the more you practice, the easier it becomes, and then it becomes simple such that you can be able to solve almost all questions that comes your way. Okay. Now this is a superposition question, and then we don't have any option than to know the rules for superposition. The question states that what? Use superposition theorem to derive the current that is flowing through R1 if only E2 remains in the circuit, right? Now, under superposition theorem, anytime we are removing a current source, what? It becomes what? Open circuited, right? Open circuit. And if you want to understand the meaning of open circuit, you can check our video on what? Superposition analysis or Thevenin's analysis, okay? And then anytime we have what a voltage source, right? Removing a voltage source becomes what? Short circuit. Short circuit means that we should just draw a line and remove the source there. Okay. So we are going to take an example. So the question states that what? If so we should find the current in R1. We should find the current in R1. This R1. If only E2, where is E2? Remain in the circuit. That means that we are going to remove E1 and what? That of the I. So we know the rules. So we'll get a resulting circuit of what? 2 ohms here, which is what? R1, right? And then we have what? Remember that this one will be open circuit, so it's more or less like it's not having any action within the circuit, so we remove it. Okay. And then we have our resistance here. That resistance is what? 2 ohms. And then our source voltage here, which is what? The E2. Don't forget E2 is equal to what? 6 volts. And then finally we have what? Our circuit completed. So the question says we should find the current that is flowing through this. Don't forget that after we have done deriving this circuit has now tends to be what? A series circuit, right? So the current, we have only one current flowing through the system. So the current in the what? In the R1, right, is the same as what? The voltage divided by the total resistance. Of course, the total resistance is just to add the two resistance together. So that will give us say some 4, and that is the same as 1.51 amps, right? That means that our answer for that is actually what? B, which is 1.5. Now let's move on to the next question. The next question states that we use superposition theorem to derive the current flowing through what? R1, the same R1, if only E1 remains in the circuit. So E1 is going to be in the circuit, but we are going to take E2 out and I out. So we are going to get a resulting circuit like this. Since we, of course, we have our 2 ohms here, which is what? R1. And then we have our voltage source here, which is the one that will remain U1, which is equal to 12 volts. And then this one will be open circuit, so we still remove it. And then finally we have what? Another resistance, which is what? 2 ohms, right? We have removed the E2, which is short circuit, so we just remove and draw a line across it. Okay. So don't forget, this is still what? A series path, just like the one we discussed earlier, right? So since the series path, we assume that it has only one current, right? So the current in the same R1 is the same as what? 12 divided by the total resistance, which is 4, and that will give us 3 amps. So that means what? Our result is actually what? B here again. Okay, let's proceed. Okay. So the next question, which is the last one, states that what? Use superposition theorem to derive the first current flowing through R1. Okay, we are looking at the current in R1 if only I remains in the circuit. So we are going to have R in the circuit. This and this will remove. Of course, we know this one will be short circuit, this one will be short circuit. So our resulting circuit will be the 2 ohms, right, which is R1, and then we have our current source here, which is what? 3 amps this way. And then finally, this is just about superposition, okay? And I said superposition is very easy. 2 ohms here. So this is what we have. Now the question states we should find the current in what? In R1 again, right? So this is a parallel path. When this current reaches here, it is going to share, right, between this side of the circuit and the other side of the circuit. So we can just use current to find what the current divider between this side and the other side, right? Of course, we know that this is 2 amps, this is also 2 amps, so it's the same current. So we can say the current across the R2 is the same as what? Because the same current output 2. So this will be the division of the 3. So 3 will divided by 2, that will also give us 1.5 amps. Or we can say that we want to find the current the same as what? The opposite resistance, which is 2, divided by the summation of the 2 to give us 4, times the total current, which is 3, and that will give us a resulting value of what? 1.5 watt amps again. Okay. So that is all under the what? The analysis we did for today. The next question states that we should find the total current flowing through R1 when superposition theorem is applied. Now you realize that the question didn't state clearly, or the question is not clear. So that means that there's an omission of something within the system, right? So they didn't tell us which one are we taking out, or we should find the R1 if all the circuits are acting. That means that we just analyze them individually. Okay. So that is the end of the road for this particular one question. We are going to meet in our next question. Bye.